You are a decision tree. You decide to click on this video, and if you stick around, you can learn how to make your own decision trees. But what are decision trees? A decision tree is like a game of 20 questions. The tree will ask a series of yes or no questions based on features which describe the potential answers. By following the questions, the computer can guess something like what your favorite color is, or if you should like, comment, and subscribe.
He's got a point.
Think of a decision tree as slicing your data into halves over and over until all of your values are grouped. This leads to very accurate fixed answers, assuming that the data provided is all trained in several possible outcomes. However, this comes at a huge risk of overfitting, and despite what gym bros may tell you, overfitting is bad in machine learning.
You should get one of these.
No.
So how do we fix this? Well, simple. We throw more trees at our problem because at first, if we don't succeed, torture your PC until it uncovers the hidden answer of life. This brute force solution is known as random forest. Think of random forest like a 9 out of 10 doctors to recommend toothpaste. Each doctor is a tree, and the random forest surveys their data to give you an average. Let's now take a look at the app that we'll be making. Disclosure: this is not real medical advice and is an example for entertainment only. Go to a doctor, not YouTube, for actual medical guidance. Acne? Well, I guess when I was a teen I alleged to have these symptoms to get out of school. The reason why acne showed up is because the dataset I have does not include enough examples to learn off of, so even with random forest, overfitting is prone to occur. Sadly, the data for this specific topic is rather dry. However, if you are interested in doing your own classification, a great free resource where I found this data is Kaggle. Still here? Post your favorite tree in the comments below. Mine is Spruce Willis. Alright, let's take a look at the code. Let's start with the TreeNode class. As you probably have guessed, building a dynamic decision tree involves a lot of recursion, and object-oriented programming is great for handling that use case. The tree class is divided into two functionalities, if it is a branch or if it is a leaf. A branch will need two child nodes, which will be for the right and left path to traverse. It will also need a threshold value and an index indicator to compare data against. A leaf will only need a value to return once reached. Now that we have our nodes, we will need our tree. The tree will consist of three parameters: a min-split length, a max depth, and an indicator on whether we consider zero variance to be acceptable. The reason why we want this final check is you may find Boolean algebra does not operate well on a tree that does not have this check. This is because Boolean algebra sometimes has variance of 0 due to the polarized nature. On the other hand, you may find abstract data will perform great without this check, as a variance 0 are far less likely. We can finally start building our tree now. To build the tree, we'll need a recursive function called buildRecursiveTree. This will take in a dataset and a depth and return a tree node. Before doing any of the fun logic, we'll need to check if our tree is at the max depth or if the dataset is too small. If so, we then want to return a leaf. If not, we will then grab the best location to split and call the function recursively for the left and right branch before returning our branch. Finally, we have an abstract function called buildTree since we need to assign this output to the root of our tree. Lastly, we have the prediction for the tree. Just like before, this is another recursive function. To make a prediction, we will need to check to see if our current tree node is a leaf. If it is, congrats, we have our prediction. If not, we need to navigate to the next branch and continue the cycle. Good work, y'all. Till next time.